what do you see on screen here? Yeah, blocks. No, what they do, what they are for. Yeah, to store something. They are also called containers. Yeah. So shipping of goods from one continent to another continent, and uh, one country to another country. Okay. So so of course we don't have to call this. Of course, these are called containers, and we can call other things also containers, where we can contain multiple items into that, right? So that is the whole idea. So okay, likewise, we have also containers in Python. Okay, so so far what we have seen: integers, float, okay, string. Uh, these are not containers. Yeah, Boolean, okay, complex. These types are not containers. Uh, so which means the container types are special kind of. These can also be called compound data types. Special kind of data types where these can contain other data types. Okay, so like we see on the screen, where you see that the big purple one, think of that as a container, and you can put other types, like you see here. We have a string here. We have this is very powerful. Okay, when compared to other programming languages, you have to do a lot of stuff when it comes to static type. Okay, so when you if you need a container, you have to go through a lot. Okay, so defining data structures by yourself, and uh, no writing those methods, or if it is a procedural language C, uh, or if it's C++, that is a lot of work. But the Python is uh, giving that luxury to us, by supporting these container data types out of the box, and we can do a lot of stuff with this. These are powerful. So like we see here, so we have the string here, we have this, these are like, think of this as you know boxes, like compartments in the container. Okay, in each one you can put other type. So one thing can you notice here, a container may contain another container. Okay, that is one thing you can notice here. Here is we have another container. Can you see here? It's like mirroring. Yeah, it has another container. Okay, so it's like a painter painting himself and himself. Okay, so how so likewise we have another container here. So this container is having a string and an integer, and then another container. Another container contains, yeah, integers. Yeah, that way you don't have limit. Okay, so like you can nest these things. You have complex number, you have float. Okay, so what are the container data types? Okay, but see, this definition, you what are container data types in Python? Any container, any type or any data structure, okay, that can provide, that can reside multiple data types. Okay, uh, that provides a way to store multiple types or multiple values into it, and there is a more technical way, more constructive way to define a container is, but for the time being, well, it makes sense when we discuss about uh, iterators, but more constructive way to define a container is any data type that supports uh, membership in operator. Okay, so that returns, okay, that may also be referred as a container, but sometimes some non-containers may also support that. But so overall, do you understand what is containers? Containers are those. Okay, so remember, we define broadly data types into two categories according to storage model, access model. Okay, uh, and so we have according to mutability. Okay, So storage, according to storage model, we have scalar and container types. Okay, yeah, and according to the access model, we have direct sequence and mapping types. And okay, according to that, mutability, we have two types: mutable and immutable types. Okay, so these data types uh, can contain multiple types, and mostly these data types also support in operator. We haven't seen that operator yet. Okay, so membership operator. And moving further, what are the container data types in Python? Okay, so tuples are container data types. Tuples. Okay, so remember, this is a heterogeneous data type. So heterogeneous data type, what you have seen here is a heterogeneous. Homogeneous means having able to store same things. Okay, like if you take a container, okay, if you go to the supermarket, that okay, the way you can put only eggs, but not you can't put tomatoes, okay, mangoes, right? So that is homogeneous, because you can't put in that container different things. But if you take a bag, you can put multiple things into that. That is heterogeneous. Okay, so okay, if you are aware of C, arrays in C are homogeneous. Okay, the way you can't put different values, different types. Okay, once you define it, declare it, should bound to that. Okay, if you make that array if you create array of characters or array of integers, you should be able, you can store only integers, an array of integers. But in Python, the container data types are not homogeneous, they are heterogeneous. They can provide a way, just like a carry bag, or basket. Okay, go to the supermarket, you can put all of the vegetables or all of the groceries that you buy. Here you can put different types. Okay, so what is uh, how do you define a tuple in Python? Okay, see, remember, see, these tuples are container data types. According to the storage model, there are two types. What are those? Scalar and container. Okay, these are these tuples are able to store multiple values into the that, and it supports a sequencing protocol. Okay, so whatever you have learned is helpful here. We don't have to learn that again. Okay, that subscription operator, brackets and referring things by index. Okay, so learn one, and you can apply to all sequence types, and this is immutable. And okay, so tuples are delimited and delimited by surrounding the delimited by surrounding parentheses. In the sense, you can define a tuple. So this is how we define. These are container data types. We can put multiple values into it, and when you declare this tuple literal, you can separate those values by comma, and to represent it as a tuple, we enclose it in parentheses. Okay, and you see tuple data type. Okay, and this is the keyword for tuple. Remember, you learned the keyword. Okay, so you can create empty tuple by calling this function. Okay, or you can you can define a tuple. You see, okay, this is tuple. Okay, so how do you define tuple? See, can you see here? Construct a tuple by any of the following events. So first one is empty, and second one is it is having element only. Again, we call these as elements here also. Okay, the different values, and we can put different values separated by comma. Okay, because you see, remember, this is a container and it contains multiple values, and this is how you can put multiple values, and you have a built-in function tuple. You can call that function uh, to create an empty tuple. Okay, so see here, how do you tuple? Here I'm defining tuple with the heterogeneous types. Okay, 2, 3, and Python. Okay, and second one, I created tuple again with the float and the string, 5 is and complex number, and then tuple. And here I'm defining a heroes, which is Batman, Superman, okay, Wonder Woman. So again, this is a tuple, okay, tuple of strings, okay, and you can refer heroes, okay, heroes, and you see I got everything, okay. So each value is separated by each element is separated by comma, okay. That is how you do. Okay, these are how many elements you have here. Heroes, 3 elements: Batman, Superman, Wonder Woman. And see, remember, this tuple is of a sequence, okay. This can be categorized container, sequence, and mutable. And since it is a sequence, you can refer elements by index, okay. So what is here, if you define what element do you have in first index? Batman, okay. And second, in at index 1 you have Superman, at index 2 you have Wonder Woman. And since I'm see, you can actually go on with this index, okay. See, if I refer heroes of -1, what you are getting? Wonder Woman, okay. But no, see, remember, forget about 7, this one, okay. Okay, so you got Wonder Woman, okay, and out of that Wonder Woman you are actually again applying slice, okay. Do you understand? From 7, return everything, so that 7, at 7, index 7 you have woman. Do you understand? If you don't understand, let me explain that one, okay. Yeah, heroes, okay. Batman, oh shit, sorry. Okay, so heroes, 3 elements you have, okay. So how do you refine refer a first element? Sorry, 0, okay. How do you refer second element, third element? Right. And you can refer, as you learned, in negative indexing is also supported, which refers the last element, okay. And the -2, which refers the first element, right? Yeah. If you give index that index that, yeah, if you give index which doesn't exist, what you will get an error, okay. Tuple index out of range, okay, for any sequence type, okay. You can't refer a value which is out of range, okay. Now tell me, if I refer index 0, what you are getting? At index 0, what do you have? At index 0 you have a sequence. Okay, at index 0 you have a string which is another sequence. Then how do you again chain? You can chain this way, sequencing, okay. The first element, okay, index 0, which returns another sequence, you can chain this subscription, okay. To refer inner sequence, okay. Here now index 0 returns the Batman. Inside a Batman, I'm referring this, okay, 2. Now you get 2. At index 2, what do you have? T. Can you see? 0, yeah, 0, 1, 2. Do you get it? Okay, let's define another thing, okay. Yes, -1. N. Okay, so let's do the slicing, okay, from 0 to, or 1 to 4. Can you see? Index 1, 2, 3, right? Do you get it? So here index 7, what do you have? See, you get index out of range because it is not of length 7, okay. Now try to refer that with the -1. What do you have at -1? This with look at this heroes. Look at these heroes. Wonder Woman. Okay, and count 7. 0, 1, 2, 3, 4, 5, 6. Space also counts. Okay, yeah, woman. And it takes only W. Okay, but if I use the colon, it returns everything. Yeah, till then. Okay, and I can also use -1. Okay, so -1 means again you will get, it doesn't take last character, last index, so that it is excluding n. Do you understand? Yeah. Okay, so that is the reason you should leave that thing. Okay? That way you had got. Okay. Yeah, you have to count. Okay, you don't. Yeah, yeah. See, 7, 8, 9, 10, 11. You have to count them. Okay, but why do you take that? Uh, pressure if you can leave it and Python returns the whole string. Do you understand? Because that syntax is supported. Otherwise, we have to sit there and count that. Okay. Uh, okay. Mm, so this is so pretty neat, right? So you learned already sequences and you can refer those elements, and that way you can see this is tuple of tuples. Okay, right? The outer one is tuple, and inside I contain, it is heterogeneous. Tuple contain one neo and integer and string. Okay, so now that way I'm able to refer, at index 0 means this one, first one neo 22, and then index 1 we got neo, right? Yeah, and see, this origin of word tuple, it came for multiple. Okay, see, if you have a single, we call it as a singleton or monopole. Okay, if you have two items, we call it as a couple or double. Okay, if you have a triple, okay, three items, we call it as triple. And if you have four items, and we refer four items as a quadruple, and quintuple for sextuple, for 6. Okay, septuple for 7, octuple. Okay, so this is a suffix. Okay, so tuple is a suffix. Okay, to refer, this is that way. uh, so you have n items, we call it as a n tuple. Okay, so that way we can, this is the origin of uh, yeah, tuple, data type, tuple we used here. That is why we call it as a this data type as tuple, because uh, the is able to store, multiple items, multiple tuple. Do you understand? Multiple. Yeah. So we call that, that is the reason, that suffix is taken, and this is referred as tuple. Okay, so you can store a multiple heterogeneous types, elements. Okay, so multiple elements of heterogeneous types. Okay, and what is another one? We have another container type is a list. Can you see here? Okay, another container type is a list. Okay, list is also a container data type, and also according to the access model, we can refer it as we can categorize it as a sequence, and it is a mutable. And see the difference here. What is uh, remember this one, tuple is immutable, and refer this one, it looks same. Okay, it's like a big brother for the tuple, but only difference is think of this as a twins, list and tuple. But okay, so this list is like the tuple is like that, but list managed to grow up as a different person. Okay, right? So both are twin brothers, and both are, you see the similarities. List is also heterogeneous, list is also container, list is also sequence type. But when it comes to that, you know mutability, so tuples are immutable and lists are immutable. Okay, so and the another difference is there, syntax is same. You can when you define a tuple using literals, we would use the brackets, and we can differentiate elements inside tuple by comma. And sorry, elements inside list by comma, same way we do for the tuple. And we have the built-in function list, and we can use that list to create empty list, or we can pass an argument of iterable to convert that into a list. And same way you can see that picture in the background. Okay, so say you can have a different values in the container, since it is list is also container, and you can nest those containers, container is having another container. Okay, since it is a heterogeneous, you can have tuples inside list and list inside a tuple. Okay, so let's see this. How do we define? Same way we use the whole thing is same, but the only same to same, but the only difference is we use brackets for our list. Because how do you tell that? Tell the Python interpreter this is not a tuple, this is a list. Okay, we instead of using parentheses, we use brackets. And the same thing, I'm defining heroes: Batman, Superman, Wonder Woman. But you can use the same subscription syntax here. So instead of putting parentheses, I put brackets here. Okay, and now I can use the same syntax. You see, sequence, it's working, right? Okay, but the one, when do you use list, when do you use tuple? The only difference do you see here is the mutability. Okay, so when it comes to list, they are mutable. When it comes to tuple, they are immutable. Okay, so we use list when we want our data to be mutable. Okay, our data structure to be immutable. So when it comes to that requirement, we choose list, and otherwise we choose tuple. Okay, and lists are having methods. Those are append, extend, insert, remove, index, count, pop, reverse, sort, copy, clear. These are list methods. And the same way we learn the methods for Python, strings in Python. We have methods for the list as well, and we haven't seen much of these methods for a tuple. Why? Because tuples are immutable. We will see that as we discuss list and tuple methods. And okay, so for this is about list and tuple.